The first one is this, t cosine of t and t sine of t. So the trick sometimes is, the best trick is to figure out what is your projection on xy plane, on xz plane, on yz plane. In here, I see these two, that's the y and z. That projection is going to look like t cosine of t and t sine of t, right? And then this is the projection yz. That in the yz plane, there looks like this spiral. It's like a circle, but the radius is increasing, so it becomes a spiral. Then looking at the other basically projections, projection x, y or x, z, they're similar, right? And xy is going to be t and t cosine of t. So that's x and that is y. So basically y is equal to what? Y is equal to x times cosine of x, right? And so that is this weird enveloping function of y equal to x, and then cosine of x is basically going about it like that. So from the feel of this, it seems like on the, let me go, next page. X, Y, Z. So I'm kind of expecting this circles. It's not quite circles, it's Archimedean spiral, right? The spiral coming out toward the x-axis, basically. And so, and the other thing that I said is this one does look very similar to that. It's just going to be z equal to x sine of t. And so it looks like, let me change color. The spiral, it's getting bigger, right? I didn't do a very good job at making it bigger, but the spiral going in that direction. And so that's the first one. Let's do part B. Part B is asking cosine of t, sine of t, and sine of 2t. It turns out, again, this is x, this is y, this is z. And I see immediately the projection on xy plane, which is cosine of t and sine of t, is a circle, precalculus or Calc2. Okay. So, and then the relationship between x and z, and let's see, I can see that the relation projection on xz plane. This is a bit more complicated. It's going to be cosine of t, sine of 2t, right? So basically, there are ways to figure this out. One of them is xz. Right? So one of them is z is equal to, what is sine of 2t is 2 sine of t cosine of t. right? It's 2 sine of t cosine of t equal to 2 square root of 1 minus x times x. Hey, this is a little bit more complicated than I like. But I can notice that every time here, t goes between 0 and 2 pi. Every time that t goes between 0 to 2 pi, z should go 2 periods, right? It's z is sine of 2t. So that may actually help me more than the projection sometimes. And that's one of those situations. Therefore, I'm going to draw the projection down here and then notice that the z, z when t is equal to 0, cosine x is equal to 1, y is equal to 0, and z is equal to what? Z is equal to 0 also. And so basically it goes like this. And it's round and it goes around on that. So one thing is that a lot of times the projections are good. In this very specific case, that I do the projections and it becomes very complicated. One thing to notice is that basically I can find the intrinsic equations that gave me that. And that is x squared plus y squared equal to 1. And then what else is there? Then z equal to 2 times x times y. And so basically, this shape is the intersection of the cylinder and the hyperbolic hyperboloid. And so basically there's a cylinder that comes up, to imagine it, and then a hyperboloid is intersecting it. So it's a rubber band around the cylinder that is now, again, these things don't go very well. I have a picture of this one. So it's a cylinder going up and a hyperboloid has intersected it. So the rubber band around the cylinder goes up and down once. Most questions like this are going to be multiple choice and matching, because we want you to be able to parameterize using your computer in future. So we give you the math of it, but as far as doing the pictures, that's something that you will do on your computer later. Okay, so I have one more left in here. E, I'm still in 13.1 to 13.3. C, T, cosine of T, and sine of T. This one is basically very useful, right? And we see it a lot. This is the staircase equation. You see it in engineering and science a lot. This happens a lot. So how do I deal with this? This actually works very well with projections. So let's do projection. And I go with these two first over YZ. And that gives me again a circle. Then I go with either one of those are very similar. Let's say XY. And so XY is just T and cosine of T, right? So X and cosine of X. So it's cosine of X. Right? And so this gives me the, it just reminds me of the helixoid, right? Helix, not helixoid. Just forget that I say helixoid. Helixoid is something else. Is not a curve. And so it's basically going round and round and in the X direction. What do we call it? Slinky? Yeah, it looks like a slinky in the X direction. So these are a little bit new material. We haven't done a lot of worksheets on them. Let's do problem 2 in here. Find a vector function that represents